What is up, everyone? Welcome to today's video. Today we're going to be going over threesome. And threesome is a relatively more difficult problem than twosome. And basically what the question is asking is, say you have an array of integers. What you're asked to do is basically find all the triplets that add up to give you 0. So what that means is, find all the numbers here, or find 3 numbers here, that when you add them together give you 0. For example, -1, 0, and 1 add up to give you 0. So that's one triplet, right? Another example is -1 and -1 and 2, right? Those 3 numbers add up to give you 0. So that's another triplet, right? So they want you to find all the triplets that add up to give you 0. And an important thing to note is that you can't have duplicate triplets. So what that means is, as you can see here, -1, 0, and 1 is a valid triplet, right? But what you can't do is also, along with this triplet, have another triplet here, for instance, say 0, 1, -1, right? Those are the same numbers, the only difference is that the order is different, right? And that's not another triplet, that's a duplicate triplet. So you only have one triplet with the same 3 numbers, right? So how we can do this is quite simple, right? So this is the example from the question, and what we want to essentially do is loop through this list, right? And basically, starting at this index, right, we have this element. So what number, when added with -1, gives you 0? Well, in this case, 1, right? So when you want to basically find 2 numbers in this vicinity, right, in this range, that add up to give you 1, because 1 adds with -1 to give you 0, right? And you want to find all the possible combinations of 2 numbers that add up to give you 1, right? Because like we said, we want to find all the instances, right? So you might have, for instance, 0 and 1, you might have 2 and -1, right? Those all add up, or like those 2 numbers, 2 and -1 give you 1, 0 and 1 also give you 1, so right? So there's more than just one instance of 2 numbers that add up to give you 1. So you have to find all of them. So how we can do this is, first of all, we actually need to sort this. This doesn't work. What we need to do is we need to actually have this sorted to actually do what we want. And the reason for this is because why we wanted to have it sorted is quite simple. Because initially we're starting here, right? We're going to start with a pointer I and a pointer j, right? So these are the same numbers that we saw before. The only difference is that the list is sorted, right? It's starting from -4, which is the smallest, going up to 2, which is the largest. And the reason we want it to be sorted is because right now we want to find 2 numbers in this vicinity or this range that add up to give you 4, because 4 plus -4 gives you 0. So, and we want to find all the possible instances of 2 numbers that add up to give you 4, right? So the reason why we have it sorted is because we can easily move, you know, the first pointer and the second pointer up or down based on the number. If it's too big, right? If the sum of this number and this number is too big, then we're going to move this down because it's sorted. So when you move it down, the sum is now becoming smaller. So if it's too small, right, if this number plus this number is too small, we're going to basically move it up because now the sum is going to be bigger, and hopefully you can reach the number that you want by moving the pointers up and down in this way. So let's take this example. We want to find 4, right? -1 plus 2 gives you 1, right? And 1 is too small, right? 1 is less than 4. So what you're going to do in this case is, because you know that this list is sorted, you're going to move I up. So in this case, there's a duplicate. So it's essentially going to be the same number, but again, in this case, -1 plus 2 gives you 1, so you would move it up, right? So in this case, the sum is greater. 0 plus 2 is 2, but it's still too small, so you still have to move or increment I up, right? 1 plus 2 is 3. It's still too small, so you're essentially going to have to increment I again in this case. And basically, once the 2 pointers are either at the same index or I is greater than j, then you know that you have to stop, and there's actually no answers, right? There's no 2 numbers in this case that add up to give you 4, so you have to stop, and you have to basically move on to the next iteration. So I'm going to basically move on to the next iteration, right? Wait, I just want to, okay. So yeah, we're going to basically move on to the next iteration. So we're going to be here, and then now I and j are here, and we go through the same thing, right? 2 numbers that add up to give you 1, right? Because you're looking for 1 in this case. So -1 plus 2 is actually 1. So these two numbers actually work because negative 1 plus 2 gives you 1. 1 added with negative 1 gives you 0. So we can add these three numbers, negative 1, and 2, to our solution set. That's a valid thing. So then after we get the two numbers, we still have to look for more because there could be more. So we increment I, and then we decrement j. Same thing here. Do these two numbers add up to give you 1? 0 plus 1 gives you 1. So that's great. We're going to add this to the solution set, negative 1, 0, and 1. And right after you do this, you're basically going to keep incrementing this and going along. But as you can see in the answer, these are the only two valid answers, right? So now you understand the gist of how we're going to solve this, conceptually. How can you actually code this, right? It's pretty simple, actually. First of all, like I said, we need to actually sort the list. So let's actually get that, out of the way. Arrays.sort, because we're given an integer array, we're going to sort it, and now it's sorted. Great. Now let's just define the variable for the solution set that we're going to be returning, because it's asking us to return a list of integers, right? Great. So call this solution set is equal to new array list. Okay, great. Now we're going to have a for loop, and I is going to be basically the index of the current element, and I has to be less than the length of the array minus 2. And you might say, well, why minus 2? Well, because as you recall from here, right, what's going to happen essentially is this is going to keep increasing and increasing. And so let's say you get to this point. You have the current index here, and you have I and j here, right? You don't want to actually go ahead here, because if you go ahead here, then basically I and j are going to go out of bounds, so it's not really going to work. So it has to have basically two spaces for it to work, right? And that's why it's less than the length minus 2. Okay, and now what we have to do in this case now is we have to actually have an if statement, right? So another thing that we have to consider in this case is duplicates, right? Because like they said, they can't have duplicate triplets. So for instance, right, in this case, remember we kind of stopped here, right? We stopped here and we found the two possible lists that would work, right? So the next thing to do in this for loop is to actually increment and go to the next one. But notice that here, if you just go to the next iteration, we're going to go through the same process. We're going to have I here and j here, and 0 plus 2 doesn't give you 1, right? But then we're going to decrement j and we're going to go here. 0 plus 1 now does give you 1. So you're going to have a repeated triplet. You're going to have negative 1, 0, and 1 again. So how you can overcome this is in the for loop, check, is the current element I'm at equal to the previous element? If it is, then just skip the logic or the code after, right? So what we're going to do here is we're going to say if I is equal to 0, or if I is greater than 0, and the number that I'm currently at is equal to the number that I was previously at, then, sorry, if it's not equal to, right? Because if it's equal to, then, we don't want to do it, right? So if it's not equal to, execute this code, and this code is basically going to look for the two numbers that add up to give you the sum, right? So the reason why we have I is equal to 0, because, if you're starting the loop, right, there's not going to be any duplicates behind you, right? So in order for this to work, right, we have to say if it's greater than 0, then the index, oops, we forgot to add minus 1, guys, sorry. So yeah, what you're saying is, if you're at the first index, that's fine, right? There's no duplicates behind you, right? So just do the code, right? Just execute the code. And once you go on to the next one, when I is greater than 0, then you have to check, is the current element I'm at equal to the previous element? If it is, then there's a duplicate. So then just skip and just go on to the next one, right? So what is the actual code? Well, the actual code is we're going to have, let's call the first pointer left, right? Left is the first pointer. Left is equal to what? Left is equal to I plus 1, right? Because it's equal to the current element, plus 1. And then the right, or the second pointer is actually equal to nums dot length minus 1, right? And then we'll have this sum that basically we want to find two numbers that add up to give you the sum, which is 0 minus the current element, right? So essentially, right, like we're here, let's say we're here, the sum would be 0 minus minus 1, so 1. So we basically want to find two numbers in this range that give you 1, right? So that's what this sum is basically, right? Okay, great. And now we're going to have the loop, and the loop is basically going to, do the checking for finding the two elements that add up to give you the sum. That's what this loop is doing. So, how do we keep this loop going? Well, the loop is basically going to keep going as long as the first pointer is less than the right pointer. So like I said earlier, once, let's just get rid of this. Okay, once, I and j, let's say, are in the same index, then you know that there's no more, no more elements that you can check, two elements that add up to give you the number, so you have to stop. So that's why this condition is while the left pointer or the first pointer is less than the right, you can keep going and checking for elements that add up to give you the sum, right? So in this case, there's three cases that can happen. The first case is the, if nums I is, if sum, right? So if the sum, the current sum, right, is, so if the sum, right, for instance, 0 and 2, this is, the sum, if the sum is greater or less than nums left plus nums right, so essentially what this is saying is, if the sum, basically the number that you want, is actually less than the sum of the two numbers you're adding, to make this simpler, just let's say less than, like here, let's add it here, just to, right? So basically, if the two numbers here, right, so 0 and 2, in this case, actually in this case we've skipped this, right? So let's just go back to here. So let's say here, I and j, right? So we're saying if these two numbers, I and j, added together, so the element at the left pointer, which is -1, plus the element at the right pointer, which is 2, if their sum is less than the sum that you need, then what do? Well, you have to actually increment, right? Because remember what we did here, right? When we had 4 as the current element, and I was here, and j was here, right? In this case, -1 plus 2 gives you 1, and 1 is less than 4, right? Because the sum here is going to be 4 in this case, right? Because 0 minus negative 4 is 4. So what we're looking for is 4. So if the sum of -1 and 2 give you 1, which is less than 4, what you have to do in this case is increment I, because this is sorted, and so the next element should, when you increment, the next sum should be greater. In this case there's a duplicate, so it won't be greater, but you would keep going, and going and going and going, right? So you would increase or increment the left pointer. Similarly here, if the left one plus the right one is actually, actually greater than the sum. So in that case, what do? Well, you decrement the right, or the second pointer, right? So the right pointer should be decremented, or decremented, how do you pronounce it? So the right pointer should be decremented or decremented here. So now the sum should be smaller. As you can see, 0 plus 1 is smaller than 0 plus 2, right? So that logic is right. And then the only other case is if they are equal. So the only other case is, for example, you found a triplet. So I and j, in this example, -1 plus 2 gives you 1, which is equal to the sum. So now what do? If you found a triplet, well, we're going to actually add it to the solution set. So solution set dot add, and how you can easily add it is just say array dot as list, arrays as list, and this basically allows you to quickly generate a list. So in this case it would be nums I, which is the current element there, -1, which is the current element, and then we would have nums left, and then nums right, so i.e. the elements where the pointers are at, right? So now you've done that, okay, great. Now what else do you have to do? Well, we can't actually, in this case, right, we have to do something. We have to actually check for duplicates. So say there was actually another -1 here, right? So what you want to do is you want to actually keep incrementing I until you get rid of -1, right? So you would basically check if there's a -1 in front of me, well, skip and then skip again, right? Because naturally, even if there is no -1, if it's just like this, once you found the two numbers, you're naturally going to go basically I and J, right? Whether there's duplicates or not, you're going to increment I and decrement J, right? But if there is duplicates, you have to continuously keep incrementing I or decrementing J until there's no more duplicates anymore. So what you're going to be doing is you're going to have a while loop, and you're saying while left is less than right, just to make sure you don't run into a out of bounds exception. And then what you say is while the number on the number I'm currently at is equal to the number ahead of me, right? What I want you to do is actually increment I. So increment the first pointer. Right? So you're going to continuously keep incrementing the left pointer or the first pointer until there's no more duplicates. And you do the same thing for the second pointer. So while, so we still have to check, right? So we don't run into any exceptions. While the element at I is equal to, wait, sorry guys, in this case, I meant to put the the pointer, right? We're checking for the pointer. We're checking for duplicates of the current element up here, right? So here we're checking for the duplicates for the pointers. So while the right is equal to nums right, in this case it's not +1, it's -1, right? And then same thing, you have to decrement the right one. And then, like I said, naturally, whether there is a duplicate or not, you have to increment and decrement the pointers, right? So now this is actually done. All we have to do now is return the solution set, and then we're done. We're good. So I think it should work, unless I missed something by accident. So if you run this, let's see what happens. I forgot a wow, I literally forgot. Okay, I added a semicolon by accident. I don't know how to write a for loop, guys. I'm sorry. I just learned how to code. Okay, so great. As you can see here, it passed, and it's actually faster than 90% of the submissions, right? And the memory is greater than 100%. But we can make this slightly faster, because here's the thing. Let's say you have, we can make it slightly faster by doing this. We can say if the current number is greater than 0, then basically break, right? And why is that? What is this doing? Well, let's look at this. If the number that I'm currently at is greater than 0, then break. You might say, wait, what are you doing? Like, what is that? What does that even mean? Well, think about it, right? If we're here, right? If we're here, sorry, no, actually, this is a bad example. This is not greater than 0. If we're here, and let's say this was extended and we had 4, right? So essentially, this is what we would have, right? We would have I here and J here. But look at this. 1, right? What added with 1 gives you 0? -1. So because this is sorted, because this is going from, negative or the least to positive, you're not going to find -1 to the right of 1. It's impossible. So you're essentially just going through a loop for no reason, right? So an easy way is just to add this one if statement, to save you the effort of going through all of this. So this should actually just speed it up by a few milliseconds or 1 millisecond even, but, this is just a bit more efficient. So if you submit this, notice what happens. It goes from 18 milliseconds to 15 milliseconds. And now it's faster than 99.74, so almost all the submissions. So this is a very good solution, right? Even though it runs in pretty much O of n squared, which is pretty much, the best you can do in this case, because, you're checking for all triplets and you're checking for triplets and no duplicates. So there you go, guys. This is a pretty good solution for threesome. And if you understand threesome, then, you're pretty good to go to actually try and solve these other challenges that should be slightly harder. So thanks for watching, guys. I know this was a longer video, but I just wanted to make sure you guys actually understand. And instead of just, putting code and then trying to explain it quickly, I would rather explain it step by step so you guys have a better idea of how to actually do it. And if you would rather me go faster or slower even, just let me know. Make sure to like and subscribe, and thanks for watching, guys.